Hello! In this video, we are going to prove the following theorem. Sine squared of z plus cosine squared of z is equal to 1 for all complex numbers z. Now first, let's remind ourselves of our definition of sine and cosine. And at this point, we've proven that cosine is an even function and sine is an odd function. That is, for all complex numbers z, the cosine of negative z equals cosine of z, and sine of negative z equals negative sine of z. And we've also proven the sine and cosine addition formulas. And we're only going to need the cosine addition formula in this proof. Okay, so now let's get to proving this theorem. To start out the proof, since we're trying to prove a statement about every complex number, let's give ourselves an arbitrary complex number. I'll call it z. And from here, we want to show that sine squared of z plus cosine squared of z is equal to 1. Well, notice we know that sine squared z plus cosine squared z is equal to this. So basically, I'm writing it this way just so that we get it into the form so that we're going to apply the addition formula for cosine. Now, using the fact that cosine is an even function, we know that we can replace the second cosine of z with cosine of negative z. But then, using the fact that sine is an odd function, we can replace the second sine of z with negative sine of negative z. And then let's just pull the minus sign out to the front. Just like that. And now we're ready to apply the cosine addition formula. So in doing so, we're going to take z to be z, and we're going to take w to be negative z. Well, in that case, this guy must be equal to the cosine of z plus negative z. And this is just cosine of 0. And then, by definition of cosine, cosine of 0 is equal to this. So we've just substituted z for 0. But this is just e to the 0. This is just e to the 0. And we know that e to the 0 is equal to 1. So this is just 1 plus 1 over 2, which is equal to 1. And so we've shown that sine squared z plus cosine squared z is equal to 1. So this completes the proof. And so yeah, that's pretty much it for this video.